Alright, so here's a quick example of a graph with a hole in it for a rational function. Again, going really quick through this one. I'm not going to do a whole lot of explaining as I go. But notice that x minus 1 and x minus 1 are the exact same factor on the top and on the bottom, so they would cancel out, leaving my simplified function to be x plus 4 over x minus 3. But the original function would have been y equals x squared plus 3x minus 4 on the top, and x squared minus 4x plus 3 on the bottom. And so there would be a hole on this graph because in the original function you could not plug in 1 on the bottom because it would make the bottom equal 0. But now that you've canceled it out, you technically could plug in 1 down here. So what you have to remember is that you can't plug in 1 in the original function, so it causes a hole in the final graph, just to remind people, anyone reading your graph, or yourself, that in the original function you couldn't plug in 1 for the x's on the bottom. So there's going to be a hole at 1. There's also going to be a vertical asymptote at 3, because 3 can't be plugged into the bottom. There's going to be an x-intercept at -4, because -4 would make the top equal 0, thus making the y value be 0. And there's going to be a horizontal asymptote at 1, because 1 divided by 1, because the degrees are the same on the top and on the bottom. So we have a vertical asymptote, like we said, at 3. We are going to have a hole in our graph at 1, and we'll get to that when we finally draw our graph. We have a horizontal asymptote at 1, and we have an x-intercept at -4 way over here. So then we do just like we did with all of the other gigantic rational function graphs. We make a line for our sine line. On our sine line, remember, we're going to put things like our x-intercept at -4 and our vertical asymptote at +3. So this one doesn't have a whole lot of sections because you have to touch this point and you have to pick up your pencil here, but you'll have a connected drawing over on this side touching this point, and then on the other side you'll have a connected drawing after you've picked up your pencil. So again, what we're trying to do is find out what the sign is. So we plug in -5 over here. -5 is a number that's in this section right here over past -4. So we plug in -5 plus 4, that's -1. -5 minus 3 is -8, so a negative divided by negative is a positive. Then we plug in a number between -4 and 3. So between -4 and 3, way over here, you got 0, which is a good number to plug in. If you plug in 0 plus 4, you get +4. 0 minus 3 is -3, so a positive divided by a negative is negative. Then we plug in a number past 3 in this section over here of my graph. So a number past 3 would be 4. 4 plus 4 is going to be +8. 4 minus 3 is going to be +1, so a positive divided by a positive is a positive. So that means my graph is going to be positive, touch this point, go negative. But remember, we're going to have a hole at 1 also. Then on this side of the graph, my graph is going to be positive up here. So let's start with the easy part. Over here past 3, we're going to have a graph that's positive, and it stays up here, so it's going to follow these asymptotes. Notice my y values are positive. It doesn't tell me the shape. This positive right here doesn't tell me the shape of my graph. It tells me where my graph is. The shape is made by this asymptote and this asymptote. So then the same thing happens over here. We're going to have a line that is coming over here. It's positive, so it's going to be following this asymptote, and then it's going to go down here to the negative numbers. But until we get here to 1, it's going to have a hole at 1, and then keep going down towards the asymptote. Again, the asymptote tells me the shape. The positive tells me where the graph is. Negative tells me where the graph is. The asymptotes give me the shape. Notice that the hole is just an open dot right there on the graph. And it's just reminding people that you cannot plug in this number for x on the original function, even though it cancels out when you factor to a simpler function. So that's what a graph of a rational function looks like with a hole in it.